On with section 4.2 then. So remember last time we started looking at logarithms and what they are. Remember logarithms are just the inverses of exponents, right? So we talked about kind of how to rewrite them in exponential form. So let's just kind of get right to maybe some solving questions where if you know what the logarithm is always asking you for, we should be able to do it. So I'm kind of exaggerating the size of the 16 there because I want to really accentuate that you're supposed to be writing the 4 tiny. The log and the 16 are normal size. Okay, so notice that I'm asking you to find the answer here. Okay, and what did I say the answer to a logarithm in general always was? So the answer to a log is the what? Yes, the exponent you need. So I gave you a longer description last time, but essentially I'm asking you to find the exponent. Okay. So what I'm really asking you for is, what do I need to raise 4 to the power of? So what needs to go in the exponent spot so that it gives me an answer of what? 16. Okay. And then notice what's the answer, of course? 2. So just to be clear, log base 4 of 16 is 2, but on a test or a quiz or something, I want to see this rewrite statement. So it's 2 because 4 squared is 16, and the answer is the exponent. Okay, so with the same kind of thought process, let's look at some with maybe a little more unusual exponents when all is said and done. So what about log base 7 of 1/7? Okay, so let's talk about what this is asking first thing. Okay, so this is asking, what do I need to raise 7 to the power of to give me 1/7 as an answer? Okay, so we need to think outside the box a little bit, but what kind of exponents give us fractions? So if we don't know that, we definitely need to review that, but what kind of exponents give us fractions? Negatives, okay? So let's just pretend like this were regular 7, right? What power of 7 would you raise, what would you raise 7 to give you 7 as an answer? It'd be first power, right? But because it's 1 over 7, what will actually be the answer then? Not 1, but what? Negative 1? Okay, so the answer is negative 1 since 7 to the negative 1 power equals 1/7. Okay, so maybe you need to rewrite that, but remember that negative exponents indicate that we have fractions. While we're on the concept of weird exponents, remember that fractional exponents give us what kind of things? Like what does something to the 1/2 power mean? Do we remember that? 1/2 power means square root. Okay, 1/3 power means cube root. So we're going to need to be able to identify these more unusual exponents as well. So let's look at a couple more examples where maybe we're asked to evaluate, and maybe the exponent is not just a positive whole number. So again, not to beat a dead horse, but what's this asking for in general? What are you being asked to find when you're asked to solve a log? You're asked to find the exponent, right? So this is asking you a specific question. This is asking, what do I need to raise 2 to the power of to give me 1 over 32? Okay, so because it's a fraction, what kind of answer am I going to have as far as the exponent goes? It's going to be negative, right? And so now we just need to figure out like how many 2's we need, right? 2 times 2 is 4, times another 2 is 8, then 16, then 32. So how many would that take then? So 2 times 2, it's 5 of them, right? So it's not just 5 though, the answer is going to be what? Negative 5, right? But that is since 2 to the negative 5 equals 1 over 32. So I want to be clear that we have some work we're showing here, but the answer is just plain old negative 5. Okay, the answer here is just plain old negative 1. All right, so what if we do have a root question? So the log base 6 of the cube root of 6. So this looks weird, but it is asking something similar, right? It is asking what? Y'all tell me. What's the question that it's really asking you? So you take the base, right? And what are you being asked to find? 6 to what power gives us the cube root of 6? Okay, so what kind of powers give us roots? We just talked about it. Fractional exponents give us roots, right? And notice it's cube root instead of square root. So what would the fraction actually be for cube root? So if it's a half for square root, what's it for cube root? It's a third. So if you're uncomfortable with unusual exponents, you're probably going to need to study those really before we go much further with logarithms. Okay, before you do your homework for this section, I would definitely make sure you understand those more unusual exponents. All right, so one more. And then we're going to talk about some just general rules we can know. So log base 5 of the square root of 5. Okay, so what does this mean? If you're going to rewrite what it's really asking, what does it mean? Yeah, what exponent do you need to raise 5 to give you an answer of square root of 5? Okay, and what's the answer? What exponent gives us square root as opposed to cube root like the last one? So it'd just be a half. If it's fourth root, it'll be a fourth. If it's fifth root, it'll be a fifth. Okay, so even, we're going to do a lot of examples today, but that's just because these problems are really, really quick once you figure out what it's asking for. So let's do a really kind of weird one. So what if the base is something like this? Okay, well, we're not going to stress out about how large that base is. We're just going to rewrite it. Okay, so what is this really asking then? What do I need to raise 121 to the power of to give me an answer of 1? Well, there's only one exponent that gives me an answer of 1 always. Okay, do you remember what exponent always gives you an answer of 1? So what power always gives you an answer of 1 no matter what the base is? No, that would be, so 1,021 to the first power would be 1,021, right? So it's not 1. So yeah, 0 power is what always gives you an answer of 1. So the answer here is 0. So that's what we're going to circle. But if the answer is 0, since anything to the 0 power, remember, is 1. So that's one of our rules that we really need to know. So notice the 1,021 was kind of unimportant, right? That could have been anything, okay? And in fact, the log base any b at all of 1 is always 0, okay? And this works for any base, because any base to the 0 power will always be 1, okay? So that's a rule that I want you to know, but to be honest, I'd rather you not just straight up memorize it. I'd rather you understand the reason for it, and that's because the exponent that you would raise b to would always give you an answer of 1. It wouldn't matter what b was, because 10 to the 0 power is 1. 1,000 to the 0 power is 1. It doesn't really matter. All right, so that is one of the rules I want you to know, or at least I want you to know how to get it. So here's a demonstration of the next rule I want you to know. Okay, So what do you notice about this log? What do you notice about the two numbers I'm asking you about? The base and the other number are the what? They're the same as each other, okay? So let's talk about what this is asking. So this means 20 raised to the what power gives me an answer of 20. Okay, so what power always gives you back itself? 1. So this would be 1, and that is since 20 to the first power equals 20. So notice the 20 part is kind of unimportant, right? But the rule is if you're finding the log base b of the same number, in other words, there's a duplicate here and here, you're always going to get an answer of 1 for any b. So do you see why I say I don't really care if you memorize these two rules? I'm putting a star by them. I want you to know them, but as far as memorizing them, as long as you know how to rewrite a log, you really shouldn't have to, quote, memorize them. You should just be able to kind of reason those out. Okay, so let's talk about the log that's on your calculator. I don't know if last time any of you tried to use the calculator, but the natural or the understood base for the LOG button on your calculator, so if you have a TI, the logarithm keys are on this left column right here, okay? Notice there's one that says LOG and one that says natural log, okay? Those are both logarithms. The LOG button on the calculator is in base 10. So if you try to punch a regular, like a log base 3 in the calculator without changing the base, which some of the newer calculators allows you to do, it's not going to give you the answer you expect because it's going to be doing powers of 10. Okay, so when you type in log of 100 on your calculator, it actually means the log base 10, even though you don't specify. So when you use the LOG button on the calculator, it's understood to be base 10. By the way, that's because our number system is base 10. Okay, and what I mean by that is we have nine digits plus 0, right? So we have 10 total digits. And then once you get past 9, you don't come up with a new symbol for 10. You just start rearranging the digits again. So we're going to punch this in the calculator, but I want to talk about what we expect the answer to be, right? What does this mean? So what does log base 10 of 100 really mean? 10 to the what power gives me 100? Okay, so what am I expecting my answer to be then? What power of 10 does give me 100? 2, right? 10 times itself. Okay, so let's go ahead and punch that in the calculator. Let me get out of the glare here. So we punch this in the calculator. Just do log of 100, okay, and notice it's going to do what we want because it happens to be base 10, so I know it's kind of dark there, but note the answer's 2, just like we thought. Okay, so just to be clear, the understood base, when you're not given one, when it's not written down, the understood base for LOG log is 10. So if you're asked to evaluate a problem and it just says log of 1,000 and it doesn't give you a base, we're going to assume that the base is 10. Okay? Okay, so that's the LOG button on your calculator, but like I mentioned before, we also have another log button, looks like LN. Okay? I usually use like a cursive L for LN, that way it doesn't look like a 1, but a lot of the calculators will have it capitalized, but LN on the calculator is actually called the natural log. And the understood base of it is actually that number E we talked about a while back. The 2.718. So let's remind ourselves what that was. It was 2.71828. 1828 forever and ever. Okay, and remember that's a number that always comes up with exponential growth. So if you see ln of 2, ln of 2 means that you're supposed to be finding the log base e of 2. Okay. Or it means, what power do I need to raise e to give me an answer of 2? Now, why do I need a calculator for that? Do you know the answer to that? Like, I don't really know the answer to that, right? Because e is not a pleasant number, right? E is 2.718, blah, blah, blah. Okay. So we're going to need a button to talk about e because e is not a pleasant number. All right, so in the last, notice log of 100 meant 10 to what power gives you 100. Okay, so what if I ask you to evaluate natural log of 100? Like I said, I use a cursive / italics L for ln because it looks too much like a 1 if you don't. Okay, so let's talk about what this means. Okay, if it was log log, or it's also called the common log, it would be base 10. But what's the understood base always for ln? E. So it's e to the what equals 100. Okay. Notice that's probably not something I could do in my head, right? Because again, e is not a pleasant number. So we're going to use the calculator for it. So we're going to do natural log of 100 right under where we did log log of 100. And notice we're going to get that the answer for natural log of 100 is approximately 4.605. Okay. Note that if we wanted to, we could check our answer. In other words, we could actually do e to that power, and we should get right about 100. Okay. Now, why doesn't it equal exactly 100? Because 4.605 has been rounded already, right? So using the same calculator, you can do e to the power of 4.605. And you should get pretty close to 100, and notice we do, right? We get 99.98, so pretty close. Okay. But the answer is what I boxed in there. The answer is 4.61. So if you raise e to the 4.61 power, you will get about 100. All right, so what about this? And this is actually going to be common for us to get as we start solving these more and more. So the natural log of e. Okay, so let's talk about what that means. So what did we say the base already is for ln problems always? The base is e, right? So it means, what do I need to raise that understood base of e to give me e? Well, that's kind of a goofy question, right? But the answer is 1, right? I need to raise e to the first power if I want to get back itself again. So what actually happens when you have natural log and e is they're actually opposites of each other. Natural log and e are, remember, inverses of each other. So more specifically, they're actually inverse operations. So kind of like addition and subtraction are opposites. Kind of like multiplication and division are opposites. ln and e are also opposites. And basically, they cancel each other out. I'm putting this in quotations because essentially, they really don't cancel each other out. They just leave an answer of 1. Okay, and 1 times something doesn't do anything to it. So essentially, they really do cancel each other out. So let's do a couple of problems. So let's do a part A and a part B for E. So let's say I asked you to evaluate the natural log of e to the 5th. And the natural log of e to the x squared plus 4 power. So we're doing these together because they're really, really similar. Okay, so let's talk about what this one means first. What does this one mean? What's the understood base for ln again, always? E, right? So what do I need to raise e to the power of to give me e to the fifth? Well, that's kind of a goofy question, right? So what power of e do I need to raise? What power of e do I need to be able to get e to the fifth? I need this to be a 5, so it matches that, right? And essentially what happens with my ln and my e then, essentially? They kind of cancel each other out, right? Leaving simply 5. Okay, so the same thing here, what's going to happen with my ln and the e since they're opposites? It's going to cancel and it's just going to leave what? Whatever the exponent happened to be, right? Which in this case is x squared plus 4. So it works the other way too. And what I mean by that is you won't see this as often, but if you had e raised to the natural log of 3 power, so in other words the e function first, then followed by the ln, they still cancel each other out no matter what order it comes in. So what happens here? These cancel, and what does it leave then?
3.
Just 3. So just think of e's and ln's as opposites. Okay, they'll always cancel each other out. This is example 14. I don't know why I wrote 4. So let's do one more ln problem, and then we're going to remind ourselves about log instead. So there's a couple of ways to do this. One thing to note is that you can't cancel ln and e when it's in the fraction, or when it's in the bottom of the fraction. So maybe it would be better for us to think about this one as a rewrite step. So what do I need to raise e to the power of to give me 1 over e to the 16th? So don't make that harder than it needs to be, right? It's going to be 16, but what kind of 16 since it's a fraction? So what kind of 16 would it be since I have 1 over that? It'd be negative 16, right? So they still cancel each other out. We just note that the 16 is in the denominator or something like that. So it would be a negative there. Okay. Another way to rewrite this is you also could have rewritten it as the natural log of e to the negative 16th power if you wish. And then you could have just said, okay, now these cancel, and you get negative 16. Okay, regardless of how you think about it, the answer is still negative 16. All right, so let's switch back over to common log or just the log type log. So notice I'm asking you to evaluate log of 10 to the 2x power. Okay, so note I did not give you a base. So what's the understood log log base when I don't tell you?
100.
Well, no, that's not the understood base, right? The understood base is what? 10. So what do I need to raise 10 to the power of to give me an answer of 10 to the 2x power? So don't make that harder than it is, right? The 10's already matched. So what does the exponent need to match with over here? Like what does the exponent need to be? 2x so that it matches what we have over there, right? It's almost a goofy question. Like what do I need to raise 10 to the power of to give me 10 to the 2x? Well, the answer is I need to make it a 2x so that it matches the right. So just like ln and e cancel each other out, log base 10 and 10 raised to a power are also inverses, and they also cancel each other out. So just like ln and e are opposites, log log and 10 to a power are also opposites. So if you're asked to find 10 raised to the log of 45 power. So before we do anything else, what's the understood base here? The understood base is what? If I don't tell you, right, what's the understood log base for LOG? 10. So notice this is 10 to a power and it's the log base 10, so what are these going to do with each other? They're going to cancel each other out, leaving only what number? 45. Okay, so it doesn't matter if the log is first or if the 10 to a power is first, just like with the E and the ln, they're actually going to cancel each other out.